Hi, this is Jim Wright, and in this session, we will talk about solid edge 2D nesting and how it can help you save material costs and time. But first, let me introduce Matthew Fresco.
Hello everyone, I'm Matthew Fresco. I'm the managing director of WashTech. We have a production facility in Querétaro, central Mexico, and we are soon to inaugurate a new office in Dallas, Texas. We basically do washing and cleaning system for the aerospace, the automotive industry, and some other industries like optical, medical, and things like that. We are using a lot of sheet metal in our assemblies, and we will see in just a minute how the solid edge solution is actually quite nice for us. It makes us save a lot of time, and we can get a quote and get ready to manufacture in a very short period of time.
Thank you, Matthew. Money. It's the lifeblood of any business. Regardless of what denomination you work in, we always need cash flow. Let's list some ways that your company can improve the bottom line. First, you can book more order contracts. Secondly, you can spend less on raw materials. And third, you can improve productivity. You can do all three with solid edge 2D nesting. Let's explore how. First, let's talk about the benefits of solid edge 2D nesting. It will automatically extract flat pattern data from solid edge files, saving you the time and effort of manually saving DXF files. It will also import the occurrence quantities from assemblies, meaning that you don't have to worry about finding out how many of a particular item are in an assembly, because solid edge 2D nesting will do that for you automatically. It has a powerful nesting algorithm, perhaps the most powerful on the planet. It uses a continuous improvement process when nesting, so that it's always improving until you tell it to stop. The job multiplier allows you to change the number of quantity for your shop. In other words, if you're building 7 of this machine this week, the job multiplier can automatically increase those quantities by that factor. The cost estimator is a quick and easy way to find the material costs for the current job. And this product has a very high return on investment. Less waste material means more money to your bottom line. This product will also work as a standalone product if you're only bringing in DXF or DWG files. When finished with the nest, you can export that data right back into Solid Edge using several different formats or to a neutral format like DXF. It has excellent summary and detailed reports, and all of this is designed to save you time, save you material, and save you money. Here is the dataset that we will be using for today's demonstration. On the left is a rendered image of the WashTech machine, and on the right is a movie of just the sheet metal parts. This particular assembly has almost 200 sheet metal parts that must be created to make this machine. Let's get started with a demo. This is solid edge 2D nesting, and we'll start it by opening up the main assembly of the WashTech dataset. Solid edge 2D nesting is now parsing through the entire dataset, over 4,000 parts, to find those files that have flat patterns in them. When it gets done, it will report back to us and show us those files along with their thickness and the material type. While 2D nesting is working on that, let's return to our presentation. As we mentioned, 2D nesting can now parse an entire assembly and find documents with flat patterns. The benefits are that improves quality by assuring all flat pattern documents are considered. It enables the import of occurrence properties, and of course, it speeds the overall process. 2D nesting allows you to sort documents by material type and thickness. Once the entire assembly has been researched, you can then choose which parts you want to nest in this particular job by the material type and by the thickness. This will help you eliminate mistakes such as choosing the wrong material or thickness combination together. It also improves productivity by making it much easier for you to group flat patterns from multiple machines or multiple assemblies. 2D nesting will now import the occurrence properties that are pulled from the top-level assembly and will place those in the 2D nesting quantity field. This will eliminate manually typing those numbers in from a spreadsheet and always ensures an accurate quantity for each part. Also, it's a huge productivity boost. The job multiplier allows a user to quickly increase quantities of selected shapes. This feature is very handy if you plan to build more than one machine at a time, because you can simply multiply all the parts in a job by however many machines you plan to build that week or that month. The cost estimator is a quick and easy way of determining what the material costs are for this particular job. Let's go back to our demo and see how 2D nesting is doing. 2D nesting has discovered several files that do not have flat patterns or blanks. That's understandable because many of these files aren't sheet metal products. However, the list will be saved in the log file so that if we are missing a shape later on, we can go back and look at the list to determine which files we are missing. Now we can sort the data by the material type and the thickness. Stainless steel 304 with a thickness of 1.98 millimeters. We choose the Open button, and now Solid Edge 2D Nesting will go in and open each one of those files and extract the flat pattern data for nesting. While that work is ongoing, let's go back to the presentation. New for 2020, the log file for Solid Edge 2D Nesting will capture data about a job. Both those files that we were able to find blanks or flat patterns for, and those files that we weren't. That gives you a better understanding of the data and an opportunity to fix mistakes, such as files that should have flat patterns but don't. Think of this scenario. If you are manually saving DXF files for other purposes, you can use Solid Edge 2D Nesting as an automatic extract and save agent. Simply use 2D Nesting to import the flat patterns from Solid Edge files, and then you can export them as DXF files. This will improve your productivity and always gives you good quality because you're always getting the latest data from Solid Edge documents. Let's see if Solid Edge 2D Nesting has extracted those flat patterns now. The list of shapes that are being imported are shown on the left. Most of them have a green box next to them, and you can see by the map key down below that green means success. There are a couple that show trouble spots. This particular file has a very tight integration for this slot. Later we can have a meeting with the design engineer to work on those documents, but for now we will remove them from the list. We can browse through the list. We can also modify, based on layer and color assignments, which of the lines should be cut and which shouldn't. For example, you can see the bend lines here are being displayed, but they're not shown over here. We can force those to be attached if we so choose. Now they show up on the shapes that will be submitted for the 2D nesting data. We'll submit this job and notice that all of the quantities have been brought in for this particular job. At this point, we can use the multiply quantity field to change the amount. We'll say that this week we want to run 4 machines. All of these quantities have now been increased by a factor of 4. Next, we specify the sheets. In this case, our cutting machine can take 3 sizes of sheets, no more than 1500 wide, but 1500 long, 3600 long, and 2800 long. We can now begin the nesting process. Notice that immediately we get results, but at the same time, we're getting continuous improvement as we get better and better nesting efficiency. At the same time, the older lists are saved in case we want to use them for a particular reason. For example, if we have a very small tailing on this particular list. While this is processing, let's go back to our presentation. In competitive tests that we ran against other nesting products, we found that on average our nesting efficiency was 12.5% better than those competitors. So, let's do a sample return on investment calculation. Let's say that you're using quite a bit of 304 stainless steel with a number 4 brush polish. Let's say that you're using about 4.5 square meters of that per week. Let's add some other materials too. Hot rolled steel, and we'll say that's 45 meters per week. Finally, we'll add some aluminum. And we'll say that's about 36 square meters per week. In material savings per week, you could have over 500 euros saved. But there's also a labor savings component here. Let's say that you're converting manually 35 DXF files per week, and that your engineers can do it in about 3 minutes, and that your labor rate is also about 35 euros per hour. That's an additional savings of 60 euros per week for a total in the first year of 31,000 euros. That's an impressive savings. Returning to 2D nesting, you can see that it's run for almost 30 minutes. You can also see that it's made several iterations as it improves efficiency. You can track this in the slider bar by seeing how the efficiency improved. Notice that after about 2 minutes, the process was really efficient. We can compare this, the original nest, with the last one by using the Estimate Material Cost button. So let's say that this material cost 100 per square meter. Our estimated material cost is 5,000. But if we go to the last nest and perform that same task, we've saved about 125 just by letting 2D nesting work for us. I can stop the nest now and export the nest either to Solid Edge or DXF files. I'll choose to export to Solid Edge. We'll export to multiple files. And we'll choose to bring them into Solid Edge as part files. Each file is brought in separately, and it takes a bit for each file to be brought in. Once the files are brought in, we can perform almost any operation we want. For example, what if we want to turn these back into solid shapes? This is where synchronous technology can really help us out. Solid Edge 2D nesting can also support odd-shaped sheets. This is important if you work in the leather goods industry. Is your inflexible system costing you money? Consider this. Some shops run the same job over and over and over again, even though they're making multiple machines each month. The result is multiple tailings like you see on the right-hand side of the screen. If you were to run Solid Edge 2D nesting every time and combine all those jobs into one, you could have one tailing or leftover sheet instead of 17. And you're not throwing away waste material like you were before. So to summarize, Solid Edge 2D nesting has all these benefits. The one that I think is most attractive is its ability to automatically extract flat pattern data from Solid Edge files. You can book more order contracts because you're more productive, you can spend less on raw materials, and you can improve productivity with Solid Edge 2D nesting. Well, Matthew, what did you think?
Thank you very much, Jim, for your presentation. It was very interesting. I think this product of yours is really new and it's growing very, very fast. I can see a lot of new capacities added to the software in the past year, and I really hope to see what you're going to prepare for the future. Thank you, everyone, and have a good day.
Thanks, Matthew. I'm really excited about the new enhancements to this product also. That's all the time we have for this session. Thanks everyone for watching.